Hi everyone. In this video, we will solve a problem to determine flexural strength of the prestressed concrete section. The question is that a pre-tensioned T section 300 mm wide by 200 mm thick, and the rib is given as 15 mm wide by 350 mm deep, and area of pre-stressing steel is given as 200 mm square, and characteristic compressive strength of concrete is 50 Newton per mm square, and characteristic tensile strength of tendon is given as 1600 Newton per mm square, and we need to determine the ultimate flexure strength of the section. Ultimate flexure strength of the section. As per the given question, I have drawn this section. See, flange dimensions are given as 300 mm wide by 200 mm depth, and rib dimensions are given as 350 mm deep and 150 mm wide. The overall depth will be 350 plus 200 550. I am assuming that the effective cover is 50 mm. Then the effective depth will be 500 mm. See, from IS 1343 page number 51 annex D, the moment of resistance can be calculated using this formula: FPU into APS multiplied by D minus 0.42 XU, where FPU is the effective pre-stress in tendons after losses. This is the tensile stress developed in tendons at a failure stage of the beam. This value need to be calculated from table 11 of IS 1343. In table 11, table 11, we can calculate the FPU value with the help of this term, right? It means that first we need to determine this term. Once we know this term, we can able to calculate the value of FU with the help of this term. See, this is the table. Here in this column you have AP into FP by BD into FCK values. Here we have two tables. In one set of column, the first one set of column will give you the values of FPU by 0.87 FP values. This set of table will give you XU by D value. Once we know the value of this term, we can able to determine value of this term and value of this term, right, for both pre-tensioning and post-tensioning. It means that first we need to determine value of this term. See, area of pre-stressing steel is given as 200 mm square, and characteristic tensile strength of the steel is given as 1600 megapascal. Characteristic compressive strength of concrete is given as 50, breadth 300, and effective depth 500. Value of this term is 0.04. For 0.04, see, for 0.04 we need to determine FPU by 0.87 FU value, and at the same time we need to determine XU by D value. Okay, we can get these values from table 11, right? See, for 0.05, 0.05, right? 0.04. For 0.04, we need to determine. See, for 0.025, 0.025, x the value is 1. For 0.05, value is also 1. Then see here, for 0.025, value is 1. 0.05, the value is 1. Now we need to determine value for 0.04, right? We know it is very clear that for 0.04 is also, for 0.04 also value is 1, right? This value is 1. Similarly, xu by d value for 0.025, xu by d value is 0.054. 0.054. For 0.05, xu by d value is 0.109. Now we need to determine the value for 0.04. This value we need to determine. From interpolation, we can do this one. 0.054 plus 0.109 minus 0.054 divided by 0.05 minus 0.025 multiplied by 0.04 minus 0.025, right? This value will be, this value is 0.087, 0.087, right? This is xu by d value. Now we need to determine xu value. Xu is equal to 0.087 into d value will be 500. Now this value will be into 500, 43.5, 43.5 mm. Now mu will be, mu is equal to fpu. Fpu value, what is the fpu value? Fpu is given as fpu. See, from here we determined, we need to determine fpu value, right? Fpu is equal, fpu value will be obtained from fpu by 0.87 fu. This value will be 1. Now fpu is equal to 1 into 0.87 into fu value. Fu is, what is the fu value? Fu value will be 1600. Here fu means fp value means characteristic tensile strength of the this is FP, characteristic tensile strength of the steel, means this value will be 0.87 into 1600, 1392 Newton per mm square. Now we can determine the mu. mu is equal to FPU. FPU means 1392 into area of a prestressing steel. What is the area of prestressing steel? It is area of prestressing steel is given as 200 into D minus D. What is the D value? D is 500. D minus 0.42. What is the XU value? The XU value is 43.5. 43.5. Now, what is the value of this one? Right? This value will be 134.11 into 10 to the power of 6 Newton mm. We can also write it as 134 kilonewton meter. See what we did here. This is the question. They asked to determine ultimate flexure strength of this section. We know the formula from table 9. What is the formula? FPU into, I am writing the formula here. mu is equal to FPU into APS into D minus 0.42 SQ. This is the formula. We can get this formula from page number 52 of IS 1343, I think, right? Once we know this formula, here we need to determine this value. This value can be obtained from table 11 with the help of this term. That's why first we need to determine the value of this one. The value of this one will be 0.04. For 0.04, what is the value of this term? This term is 1. And for the same 0.04, what is the value of XU by D? XU by D value is 0.087. From this we can determine XU value, and from this term is 1, right? This term is 1. From here we can determine the FPU value. FPU value is 1392. Once we know the values of all these parameters, simply we can substitute and we can get the answer. This is our answer. mu is equal to 134 kilonewton meter.